At this point, we have the missile sim, and now it's time to start sourcing volumes. So we've already mentioned in our outline that we want to separate the density from the combustion because those two things happen at different locations. The density is primarily from the ground, whereas the combustion happens a little bit above the ground and is going to take on a different shape. So, starting with a new geo network, we're going to call this our large plume build. And both the density sourcing and combustion sourcing are going to happen in the large plume. Again, the idea is that we'll make the main sort of cauliflower smoky column, and then after that we'll have the spikes come through. So that's going to be really the main portion of our sim, but let's just call this our large plume build. Starting with an object merge, let's bring in our terrain. It's going to be under combined geo islands, colliz polys out, and let's also bring in our missile sim. In my network, you'll see multiple GeoNets for the missile sim because I always test my stuff out over here first. So that's why you're seeing multiple missile sims going on. But that is the missile sim that we just got done doing. When it comes to the density, how are we going to do this? Well, let's start with what we know. We know that we'd like to cover a large area of the terrain and have particles moving up from that because, again, that's what happens in reference, right? The Earth is being pulled upwards with the force of combustion and everything else that's going on. And so we're going to have particles, they'll be flying up in the air, and we need some sort of way to section off a piece of geometry like that to emit particles from. Now, your first thought might be, okay, well, if I want to mask off a section here to do that, I can just use some spheres, right? And the problem with using spheres is that we don't really have an easy way of, let's say, having a missile hit the ground, maybe expand, and then shrink back down. We don't have an easy way of doing that unless you want to keyframe all of that, which is an option. So that's not quite ideal. Instead, what we could do is utilize the pyro burst source, because on this node right here, we already have those animation controls built in. If I go to our pyro burst source right now and look at the default animation that's going on, it's nice to control how many frames I want. So if I want 10 frames, it's nice to control the expansion over time, so I can really just dial in exactly what sort of animation. And if I want it to shrink back down, I can easily do so by doing something like this. And so the fact that this is all built into the pyroburst source is something that we can leverage in this situation. Now, I'm sure some of you guys are saying to yourself, okay, Tyler, that's really cool, but why can't we use the Pyro Burst SOP? Doesn't that have everything we need? Well, not quite. If the Pyro Burst SOP goes off like this, and all the shapes are originating from one central location, that's not what we really see in our reference. And to really show that, let's take a look at reference one more time. Realize that, yes, even though there is a central location of where the bomb goes off, that's more to do with combustion, whereas where the dirt comes from covers a much wider area. So as we go forward here, watch what happens. We have this whole area where dust is going upwards. And it's not like everything is coming from the center and going out. Some areas right here are going more vertically than that. So we have, let's say, a vector going up, if you just follow my mouse, like that, and like this. It's not coming from the center like that. And unfortunately, the Pyroburst SOP is mostly designed for things coming from the center. So, for that reason, and because we'll actually gain more control via this method, we're going to mask off an area of the terrain, not rely on the pyro burst SOP for the density. And instead, we're going to copy some spheres, or maybe even some metaballs to this, and use that to mask off a section of the terrain. Let's plug in the missile sim to our pyro burst source right here, set the start frame to use attributes, and we will notice this will start at frame 1 no matter what we do. Not sure exactly why it does that, but the solution is fairly simple. If we go plug this into a switch and we have a null over here, we can basically just say that if the frame is, let's say, less than 15, then that will allow the null to take place instead of the pyro burst source. So that gets rid of this initial burst right there. Now, if we go to frame 30, there is the first hit. We have all the animation. That's super cool. We don't need all these points though, because again, we'll copy some spheres over here. So let's go to our burst shape, go to our number of trailings, turn that down. Maybe take the trailing separation to something right about there. We can also mess around with this length, so that might be just fine. And we also want to increase the size. Now, as far as the size on this density goes, again, we're just trying to concern ourselves with how far out these spheres are going to be. So this might be a good time to copy over some metaballs to these points. What it does is that anywhere where there are points, it's going to make this blobby mesh. And if we turn up the weights, as you can see, it kind of increases the influence of where those spheres are. So anyway, it'll make sense here in a minute. But let's say that we actually take our trailing separation down a tad bit. So we go something right about there. Gives us this whole blob. From here, we can convert meta. That'll give us these polygons. And then from there, we can convert this into a VDB. So VDB from polygons. If we do a fog VDB and we say fill interior in a volume slice, as you can see, this is kind of like a heat map starting from the center and going on outwards. So that's really cool. This gives us the ability to have more density where the initial impact happens, which would make sense. But now we can fade this off towards the edges however we'd like. Going to increase the size of this a bit more. So let's say maybe right about there. And from here, we can use a volume wrangle to change the fall off of these values. So if we say density is equal to a channel ramp called density underscore ramp, and we use the original value of the density field, now we'll have the ability to, let's say, take that influence and change the fall off. So maybe we want to have this go out pretty far and just have a slight influence along the surface, like along here. If we want to do something like that, we can make our ramp look something like this, and then maybe even turn up the scale a bit more on the pyro burst source. So maybe a value of 8 on that. It'll take a second because we are getting to a high volume count here, but look at that. Pretty cool. Okay, so from here, we now have the ability to use this as a mask for wherever the particles spawn for density. However, we actually haven't had any sort of attribute yet that controls this. So let's go back to our terrain, and we're just going to use an attribute noise to define the scatter density attributes. So we'll go here, we'll say scatter density, we'll create a viewport visualization right there, right click, scatter density, turn that on. Be sure that this is on as well. And then we'll say that we'll define a minimum and maximum just so that we can see this. We'll keep it at that for right now. This is a float value. enable the remap ramp to give it a bit more contrast like this. And then I found that an alligator noise is quite nice because that'll give us little pockets where we have lots of intensity going on for the particle emission. Let's take up the element size like this. And then if we bring over this distribution, as you can see, we end up with something right about there. We don't have enough topology for this though, so let's use a subdivide. And now we can really see what that noise is doing. So right now, if we were to bring this into a particle sim, everything would be, making particles based off of this noise. But if we take this and multiply it against the mask that we have over here, that will isolate this effect. So let's create a point wrangle. First of all, let's say that we want to affect the scatter density and set that equal to itself times the volume value that we'll read over here. So we'll say the vol sample val. And what is that vol sample val? Well, let's use the volume sample function to sample that density volume. Click on the text, press F1. Let's see what ingredients we need to make this function work. We'll go through input number 1. We're looking for a field called density, and we'll take our current position for sampling. So now we go and we do this, and I believe that ought to work. Oh, and we need to also define this as a float variable right there. And now as you can see, we've isolated that mask. And what's cool is that as soon as that missile hits, again, we see it expands and then contract. We'll obviously cache this out, but that gives you the overall idea, right? We have this area of activation and then it shrinks back down, as it would if you actually had a bomb hitting that surface area. To speed up the performance on this, we can go to our subdivide and only select the faces that are relevant. And if we go to our little brush select right there, and we also say select visible geometry only, we can just paint out all the sections we want. Now, will this cause an issue? Yes, it will, of course. But if we change this to open subdiv by linear, that will fix those areas where it was opening up the mesh. So even though you would never want to render this geometry right here, when it comes to our mask, this gives us the extra resolution we want in the areas that we need. Also, on the convert meta node, we can go to our LOD section and change this detail level to something lower, like 5 as an example. We don't really need all that resolution because we're making a volume like this anyway. And so the combination of fixing that subdivision and changing that meta 1 made a pretty substantial difference on how quickly that performs. Anyway, in the next video, let's check out how to bring this into a PopNet and create some particles for sourcing.